My today presentation is about rocket science explained simply. First of all, we come to introduction. Rocket science is an interdisciplinary branch of engineering and physics specially dedicated to the design, development and operation of rockets and spacecraft. It basically involves the detailed understanding of aerodynamics, propulsion system, material science and control mechanism. The primary objective is to master the principles that facilitate the efficient and precise movement of vehicle through space. That is actually the introduction, the brief introduction of rocket science we have mentioned. Next. If we talk about its significance in space exploration and satellite launches, so we can say rocket science is a paramount significance in space exploration and satellite launches. In space exploration, it enables the launch and precise navigation of spacecraft, facilitating mission to explore celestial bodies, study the cosmos, and gather valuable data. In satellite, rocket science plays a crucial role in placing satellite into specific orbits for purposes such as communication, weather monitoring, Earth observation, and navigation. The precision and efficiency of rocket technology are fundamental to the success of these missions, contributing to our understanding of the universe and improving communication and observational capabilities on Earth. That was just the significance, the brief significance we were mentioning here. Now we talk about what is rocket. A rocket is a vehicle that utilizes controlled explosion of propellant to generate thrust. The basic principle involves the expulsion of high-speed exhaust gases through a rocket engine propelling the vehicle in the opposite direction, adhering to Newton's third law of motion. This method allows to operate in a vacuum of space where traditional means of propulsion such as engine relying on the atmospheric oxygen are ineffective. As we have mentioned earlier, that the very first principle of rocket science is that Newton's third law of motion, with which we are very familiar that to every action there is an equal and opposite reaction. So rockets are crucial for space exploration, satellite launches and various applications requiring control and powerful propulsion. In a rocket system, fundamentally there are three components that are essential. First one is the rocket engine. The rocket engine is the core component responsible for generating thrust. It expels high-speed exhaust gases in one direction, propelling the rocket in opposite direction, adhering to Newton's third law of motion, as we have discussed it earlier. Second comes to fuel. The fuel, also known as propellant, is the material that undergoes controlled combustion in the rocket engine. It releases energy in the form of gases, creating the thrust required for propulsion. The selection of propellant is crucial and depends on the factors like efficiency and intended applications. And the third fundamental component is the payload. The payload is a cargo and equipment or rocket is designed to carry into space. It can include satellites, scientific instruments, or human occupants in the case of crewed mission. Ensuring the safe and efficient transport of the payload is the primary objective in rocket design. These components work together to enable space exploration, satellite launches, and various missions requiring controlled propulsion into space. Now we come to how rocket works actually, and what are the fundamental principles of rockets. The very first and the basic principle is Newton's third law of motion. Newton's third law of motion states that for every action there is an equal and opposite reaction. This fundamental principle in physics implies that the forces two objects exert on each other are always equal in magnitude but opposite in direction. In the context of rocketry, it means that the expulsion of high-speed exhaust gases that we call action from a rocket engine result in generation of thrust that propels the rocket forward, which is opposite direction. So it's completely applicable on the Newton's third law of motion. This law is crucial in understanding and designing a rocket propulsion system as it forms the basis for how rockets achieve movement in the vacuum of space. Now we talk about the parts of rockets. So the first one is rocket body. which we also call airframe. The rocket body, also known as the airframe, provides the structural framework for the entire rocket. It includes the nose cone at the front, which reduces air resistance, and the body tube, which house other components. The body serves as the outer shell protecting and enclosing the internal elements. Second is payload. The payload is the cargo or equipment that rocket is designed to carry into space. It could be satellite, scientific instruments, and so on we have discussed. Third is the fins. Fins are attached to a lower part of rocket body and play a crucial role in stabilizing the rocket during its flights. Number 4 is engine rocket motor. Rocket engines or rocket motor are responsible for generating thrust to propel the rocket. They work on the principle of expelling high-speed exhaust gases in one direction following Newton's third law of motion. Now we talk about types of rocket engines. There are mainly three types of rocket engines: liquid fuel engine, solid fuel engine, and hybrid engines. Now we will study in detail each of them. First we come to liquid fuel engine, and the image of NASA is shown below. You can clearly see, first of all, what's the description. Liquid fuel rocket engine use liquid propellants to store in separate tanks. The propellant are typically a liquid oxidizer and a liquid fuel, and they are mixed and ignited in the combustion chamber. As you can see here, this is oxidizer and this is fuel, and this one is combustion chamber. And what are advantages? Precise control of thrust, allowing for adjustment during flights. The ability to shut down and restart the engine enhances mission flexibility. And what are the challenges? Complex design with indirect plumbing and valves require more sophisticated engineering. So these are a few description and advantages and challenges with liquid fuel engines. Now we come to solid fuel engines. Solid fuel engines use a propellant that is in solid granular form. The propellant is preloaded in the rocket motor, causing an ignition indicates the combustion from the outside. As you can see, we have a very clear image of solid rocket engine. And advantage is simplicity of design, making them reliable and cost effective, well suited for military application and booster stages of launch vehicles. And if you come to challenges, the lack of throttling capability. Once ignited, it burns until depleted. Limited control over the combustion process. These are the challenges with the solid fuel engines. Now we come to hybrid engines. Hybrid rocket engines combine feature of both liquid and solid propulsion. Typically, a liquid oxidizer is used with a solid fuel. The oxidizer is injected to the combustion chamber to burn the solid fuel. Some of the simplicity and safety of solid rockets combined with the controllability of liquid rockets can be more flexible than solid rockets. And if we talk about its challenges, so with hybrid engines, engineering challenges in managing the interaction between the liquid oxidizer and solid fuel. Complexity lies between liquid and solid system. So these were the three engines we were discussing, its description, advantages and challenges. Now comparably, if we comparing these three engines, so each propulsion method has its own set of advantages and challenges, and the choice depends on the specific requirements of the mission or application. Liquid fuel engines are often used in sophisticated space missions. Solid fuel engines are employed in military applications and boosters, while hybrid engines offer a middle ground between the two. Now you can clearly relate these three as I have mentioned the diagrams, so we can have clear understanding of the engines. Now we talk about the stages of rocket launch. Multi-stage rockets. What are multi-stage rockets? Multi-stage rockets are vehicles designed for space travel that consist of two or more distinct rocket stages stacked up on each other. Each stage has its own engines and propellant tanks. The fundamental idea behind the multi stage rocket is to discard the spent stages as they consume their fuel and become less efficient. This shedding of stages reduces the overall mass of rocket, allowing the remaining stages to accelerate the payload to higher velocities. The first stage typically provides the initial thrust, the first stage, yeah, and during liftoff, and once its fuel is depleted, it is jettisoned. This shading of stages actually continues until the final stage, often a smaller and more efficient stage designed for the vacuum of space carries the payload into its intended orbit or trajectory. Multi-stage rockets are the key design in space exploration and satellite launches, enabling the inefficient use of propellant and achieving the high velocities required to reach orbit or escape Earth's gravity. They are a practical solution to the challenges of carrying enough fuel to escape Earth's atmosphere and reach space. Now we talk about the rocket equation, which is the main part of this presentation and which is very important to launch any rocket, or in rocket science we must have to discuss it. Without rocket equation it will be almost impossible to launch any rocket or to discuss anything regarding rocket science. So in the rocket equation also known as Tsiolkovsky rocket equation. Tsiolkovsky rocket equation. It is a fundamental formula in astronautics that quantities the relationship between the velocity of a rocket, the exhaust velocity of its propellant, and the rocket's mass ratio. The equation is expressed as I have mentioned the equation, you can clearly see, and what term representing has been described here. Understanding and applying equations fundamentally to the success of space mission, as it provides a quantitative framework for evaluating and optimizing and performance of a rocket system. Importance in space travel, yeah, it has a much importance in space travel. Efficiency assessment, the rocket equation is crucial for assessing efficiency of a rocket design. It helps engineer understand how much velocity a rocket can achieve based on its mass and characteristics of its propellant. Mission planning, by calculating the delta V, the rocket equation aids in mission planning. It determines the capability of a rocket to reach specific orbits, travel to distant destinations, or perform maneuvers in space. Fuel optimization. Engineers use the rocket equation to optimize the design of a rocket by considering different propellant options, engine efficiencies, and mass ratio. This optimization is vital for maximizing payload capacity and achieving mission objectives. Spacecraft maneuvers. The equation is essentially for planning orbital maneuvers, residuals, and transfer between celestial bodies. It guides the design of propulsion system for precise and efficient space exploration. And the main thing is the challenges in rocket science. Now, on the top, we have mentioned gravity. The first challenge, Earth's gravitational pull, does a significant challenge to space travel. Overcoming gravity requires a powerful force and requires much generous sufficient thrust to counteract this force during liftoff. Solution: multi-stage rockets are used to shed weight as fuel is consumed, allowing the remaining stages to reach higher velocities and escape Earth's gravitational influence. Escape velocity challenge. The escape velocity is the minimum speed an object must reach to break free from a celestial body gravitational attraction. For Earth, this velocity is about 11.2 kilometers per second, about 33 times speed of sound. Solution: rocket must attain and surpass the velocity to reach orbit and travel beyond Earth's atmosphere. Achieving such high speed requires careful design, powerful engine, and efficient fuel usage. Atmospheric drag. This is the fourth challenge for the rocket when it comes to space missions. The Earth's atmosphere exerts drag on the rocket during ascent. This drag force can impede the rocket acceleration and increase fuel consumption. And the solution for atmospheric drag is rockets are designed with streamlined shapes to minimize air resistance. They ascend quickly through the denser lower atmosphere, and once in space, they are no longer affected by atmospheric drag. And the last challenge is heat and friction. Atmospheric re-entry generates intense heat due to friction with air molecules. These can pose a threat to spacecraft and their occupants. So the solution for the heat and friction challenge is thermal protection systems such as heat shields are employed to absorb the dissipate the heat during re-entry, ensuring the safety of the spacecraft and its contents. Now, overcoming these challenges requires a combination of engineering innovation, careful mission planning, and ongoing scientific research. These complexities involved in achieving space travel underscore the need for precise calculation, robust technology, and a deep understanding of the physical forces at play. If we talk about the future of rocket science, we have briefly explained here plans for future space exploration missions. On the top, we have put commercial space travel. Objective is continued development of commercial space travel with companies like SpaceX, Blue Origin, and other working on suborbital or orbital space tourism, as well as potential lunar missions. Secondly, International Space Mission, which we call briefly ISS. Objective is ongoing research and international collaboration abroad. The ISS plans for the eventual transition to new space habitats and platforms. Third is Europa Clipper, which is NASA. Objective is investigating Jupiter's moon, Europa, which is believed that to have a subsurface ocean. The mission aims to access the moon potential habitability by studying its surface and subsurface composition. Gateway Lunar Outpost. Objective establishing the Lunar Gateway, a space station that will orbit the moon to serve on a staging point for crewed mission to the lunar surface and beyond. And finally, SpaceX Starship. Objective is SpaceX Starship is intended to be a fully reusable spacecraft capable of carrying both crew and cargo on mission to the moon, Mars, and beyond. It represents a significant step in the development of interplanetary travel. And the future of space exploration is dynamic with new plans and missions continually emerging as the technology advances and our understanding of cosmos deepens. That was for today. Hope you got it. Thank you.